Hello, mathematicians. Today, I am really excited because we get to talk about a really tricky kind of special shape. I love this shape just because it has its own qualities that make it super duper special. Can you guess what it is? Hmm. Let's look and see at some examples that I brought with me today. Well, that's the ceiling. That's not the examples I brought today. Here are some examples that I have with me on what shape we are going to be working on. What do you think? By looking at these items, do you think that you can guess what shape are we going to be talking about today? I have a Post-it note. I have a block. I have a cube that has this shape on the bottom. I have some of our letter tiles, our L and our U. And this is actually called a flat, and it's part of the blocks that we'll use later on in the year. What do you notice about all of these shapes that you see right here? What are these shapes? Did you say a square? Did you say a square? Yeah? Awesome. They are all squares. And do you know why those are all squares? What makes each one of these a square? What does a square have to have? Anybody know how to describe exactly what a square needs to have in order for us to call it a square? Let's look again. Here it comes. So, one thing that you could tell me about a square is that it has how many sides? How many sides does a square have? 1, 2, 3, 4. Yeah, it has 4 sides. This one has 4 sides too. 1, 2, 3, 4. In fact, they all have 4 sides, right? Because a square must have 4 sides. What else does a square have? Who knows that fancy schmancy word that means, it's another name for these things right here, these corners. What are those things called? Vertices. Great job. They're called vertices. Yes, these are called vertices, and it's another fancy name for corner. How many vertices must a square have? Yes, a square has 4 sides and 4 vertices. Now, there's something else really, really remarkable about a square, and I'm going to show you exactly what I'm talking about. I have a string here, and I'm going to show you a little bit about how this string is going to tell me that this is a square. If I measure and I put my string to that side, see that? If I just move my hands this way, I don't need any more or any less string. If I move my hands to the bottom, I don't need any more or any less string. And if I move this way, I don't need any more or any less string. Why? What do we know about the sides of the square? Let's try it on this one. I'm going to measure the side, and it's about this long. Now I'm going to measure this side. It's the same length. What about this side? What if I measure this side? It's the same length. What if I measure this side? It's the same length. All of the sides are the same length. Length means how long something is, right? The distance from one spot to another spot. That's the length. And on a square, all of the sides happen to be the same length. That's what makes a square special. That's what makes it so cool, because it's different from other shapes. All of the sides have to be the same size for us to call it a square. Because guess what? Let me show you something. I have another shape. It's right here. This is what shape? We did this shape, didn't we? What shape is this? This is a rectangle. Now, a rectangle has 4 sides, just like the square. A rectangle has 4 vertices, just like the square. But a rectangle cannot be a square. Why not? Why can't the rectangle be a square? What is special about the square that the rectangle cannot be a square? What is special about it? The square, all the sides must be the same size and length. On a rectangle, we have 2 long sides and 2 short sides. Not on a square. They're all exactly the same. And that is why the square is super special. 4 sides, 4 vertices, and all the sides are the same. I have a question for you. If I turn my square this way, is it still a square? It is. Do you know why it's still a square? Because it still has 4 sides, 4 vertices, and all the sides are still the same length. So even if I have my square this way, or if I turn it on its point, look, on its point, I can turn it. It doesn't change. It's still going to be a square. And the reason why is only because of those 3 things: 4 sides, 4 vertices, and all the sides are the same length. Let's do a little square work. What do you say? Okay, so you're going to need your glue stick and you're going to need your shapes. Okay, and just like all the other times, we're going to cut out these shapes on the lines. Let me get my camera back down on my paper so it's not pointing up at the ceiling again. Okay, so here are your shapes. They're all, this paper out of the way. On here, you're going to cut them out, right? Snip down the center, snip, 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 cut out all your shapes. And then you're going to have 2 groups. You're going to glue your pictures onto your paper. This we like to call a T-chart because it compares 2 things. On this side, you're going to paste or glue all of your squares. On this side, you're going to glue all of the shapes that are not squares. Squares must have 4 sides. So if it's not closed up, is it a square? No. If it is turned sideways, is it a square? It can be. Are all the sides the same size? Are there only 4 sides and 4 vertices? If it is, then you're going to glue it on the square side. Okay. Then you're going to turn your paper and you will be on this page, page 566. And let's do the first one together. It says, color any squares. Tell why your answers are correct. And if you notice, this shape right here is colored in. It's colored in orange. And it is a square. And it's a square because it has 1, 2, 3, 4 sides. 1, 2, 3, 4 L-shaped vertices. And all of the sides are the same length. Now, this is a special rectangle because it has 4 sides and 4 vertices. But it's special because the sides are all the same size. Is this a square? Nope, it is not. It is not a square because we have 2 short sides and 2 long sides. Not all the sides are the same, so it is not a square. In this row, color any squares. Did you color the green one? I hope so, because that is the only square in that row. It has 4 sides, all the same length, and 4 vertices. Color any square in this row. Did you find it? Is there more than one? I'm going to give you a hint. There is more than one in this row. One of the squares is turned on its side. Make sure you're looking for 4 sides, 4 vertices, and all the sides are the same length. And then you're going to do the same for the bottom row. Is this a square? 1, 2, 3, 4. 1, 2, 3, 4. All sides are the same length. What do you think? Is it a square? This is actually not a square. Do not color this one in. This is a special shape, and we will learn more about that shape, but there are not L-shaped vertices. There's some skinny vertices and some more open vertices in this shape. It's a little tricky, right? They are not L-shaped vertices, so it cannot be a square. Your square needs to have these L-shaped vertices. So this one does not count. But this one does. What about this one? Is this a square? I think you know the answer to that. And this one definitely does not have 4 vertices. It has more than 4 vertices. When you finish coloring in your squares, turn your paper over. And then for 1 and 2, you're going to do the same. Color any squares. And then tell somebody why. Why did you color those? Why is your answer correct? You can even take a video and tell us why you chose the squares you chose. Number 3 are going to trace the shapes that are squares. So now you have to draw your straight lines and make sure that you have those points or corners or L-shaped vertices when you're tracing. I don't want to see any round corners. You know why? That would make it a curve and then it wouldn't be a square anymore. Straight lines and pointed L-shaped corners. Make sure you're only tracing the squares. Then tell how many sides it has and how many vertices it has. On the final page, you have a house. You're going to use squares and rectangles. You learned about those rectangles. They look kind of like a square, but they have long sides and short sides. Look kind of like a door, right? They look kind of a little bit like a door. So you're going to use your squares and triangles to draw 6 windows and 1 door on the house. The directions are very specific. 6 windows and 1 door on the house. And then you can color the house. Okay. 6 windows and 1 door using only squares and rectangles. Be sure to take pictures of your work and show us what you've done. I hope you have fun making that house of squares and rectangles, and I hope that you remember that what makes a square so special? The sides all have the same size, length. The length is the same size, right? Okie dokies. I look forward to seeing your work, as does Mrs. Torres. See you soon.